more often in the formula when we actually do the problem. Okay, so it says if an object, so like think about throwing like a penny or something, thrown upward, its approximate height in feet is given by, this is just a general formula, h equals negative 16t squared plus vt plus c. Okay, I'm going to write this to the side. Where you guys are used to seeing the x, they use the letter t in that formula. And where you guys are used to seeing y, they use the letter h for height. And so it says in the formula there, I'm going to fill in the blank here, t is actually the time the object is in motion. Specifically, this is in seconds. V in that little formula, which I haven't related to a vertex or anything yet, but V in the formula is the initial upward velocity. Does anybody know, like, what might be more common word for an object's velocity?
Acceleration.
Yeah, it's the speed. It's like the speed that the object is traveling at. Exactly. Acceleration, speed. I'm going to write speed because it's a smaller word and I can fit it better. So initial upward velocity, acceleration, how fast is the object traveling? That's what that's asking about. And then C there, that just like a constant basically, it's the initial height of the object. So for example, some of the questions might say, a rocket is launched off a cliff, like it's not launched from the ground, then it would have an initial height of some kind. So they have to tell you that in the problem. Now, the other thing I was going to just draw your attention to super fast, you'll notice this has the number, this negative 16. The reason that number is always in that formula, negative 16 feet per second is just the measurement of the acceleration or the force of gravity on an object. So that's just gravity. That's as you drop something, it travels negative 16 feet per second. That's how we would measure that. Okay, so there's other formulas that are similar to this that would be like in meters per second, or so there's some other alterations to this formula, but I'm going to focus on this one. So all these pieces should be in feet per second when they give you this information, or feet or seconds. So the first problem here, we're just going to plug some numbers in. So it says a firework is shot upward with an initial velocity of 80 feet per second. So that initial upward velocity, this 80 feet per second, that number is just going to go in place of the V. And it says the firework is on a table this is not exactly 3 feet or anything, but think of like I'm going to launch this from the table. So it's 3 feet above the ground. That would be the initial height. So that would be the C value. And so we have everything we need to fill in that little formula. So it just has height and time as the variables. So if I go back, if you look at this formula right here, the height of my object, negative 16 multiplied by your time squared, plus I'm going to put in the 80 for the velocity multiplied by the time, and then plus the initial height, which it tells us this little firework is on a 3-foot table. So the 3 at the end of that problem there is based on the fact that we have this firework sitting on a 3-foot table. Okay, now I'm going to ask you a couple of questions, but let's just draw like just a general picture. This is just a sketch. It doesn't have to be perfect. So I don't know, maybe I'll just label this with like a little 3. So I know that the firework is on a table that's 3 feet off the ground. So if this represented my little firework, here we go. And I'm going to launch it up in the air, and then eventually the force of gravity will bring it back down to the ground. So the x-axis would represent the ground there. Now, in this case, actually the x-axis represents the time. Me coming back down to the x-axis would represent that I'm on the ground, because the y-axis is going to be the height of your object. So that's why I put the 3. I'm going to start at 3 feet. We're going to launch it in the air, goes up, and then gravity is going to pull it back down. So my first question here just says, what's the height of the firework after 1 second? Like, how would I figure that out?
Plus 16 feet, plus 3, so 19 feet.
But we're not taking into account the velocity. Like, how would go ahead. You can just actually use the formula. So the T in the formula is the time. So if I know 1 second, I can plug in that 1 second for the T. So t equals 1 here, if it's 1 second. So this is where I thought you guys would want your calculator because it'll be a little bit faster. Everywhere I see a t, we're going to just replace it with the number 1. And we can do this by hand or just use the calculator if you want to simplify. Question?
I see how you got the ADT and through like the B and C value to give the the velocity and able to where's the -16 here?
That's the force of gravity for any object. Negative 16 feet. Like if I drop this, that's going negative 16 feet per second. That's for Earth. It's for Earth. So like, and you could literally just like if I drop that, that's going negative 16 feet per second.
Is there a different one for different reasons?
Yeah. So like, I don't know all of them. I know the meters per second is negative 4.9, but yeah. So we're just going to use this one though. Yeah. But that's where that 16 is from. That's a negative 16, and it's negative because it's pulling it back down to the ground. So that's where your force of gravity. Really good question. Okay. Anywho, let's figure this out real quick. So you guys are probably way ahead of me. Don't forget to square the 1. People always forget to square that first term. I don't know why I put an extra set of parentheses there. 80 times 1 and then plus 3, and we should get, this is 67. Now, that's the height of the object. So basically on the graph, that would be the point 167 would be where we'd be at after 1 second. Okay. Now, I'm not going to draw on the graph just yet because I'm going to ask you these next 2 questions, and these are really what today's kind of all about. Part B here says, in how many seconds will the firework reach its maximum height? Okay, if you guys are thinking about this lovely little picture, where on that graph would the maximum height be at? Like at what point? Vertex, right? Okay, so maximum, this is going to be that's the maximum height that it's going to reach it. The x coordinate, or in this case, the t coordinate of that point will be the time that it takes to reach that point. Okay, so it says, in how many seconds will the firework reach the maximum height? This is just the x coordinate of the vertex, which is actually t in this particular problem, the way that formula is set up. Sorry, that doesn't really look like a t. Okay, if you guys remember, if you have standard form, which is what we have here, the x coordinate of the vertex is negative b over 2a. And especially for today, this is going to be super important. We want to take whatever that opposite of b is and divide it by whatever the product of 2a is. We want to figure out what the bottom of that fraction is. So if you look back up to your formula, right, what's my b value? The 80, exactly. Okay, so it's positive 80 in the little formula. So opposite of b would be negative 80. And we're going to divide by 2 times our a value. What's our a value? The gravity, yeah. Okay, now either put parentheses around that or just figure it out. This will be negative 80. 2 times negative 16 is negative 32. And when you divide a negative by a negative, right, the negative's going to cancel out. So this is actually going to be positive, but it's not a nice number. So let's just do 80 divided by 32. Okay, the x coordinate of the vertex, which the way that equation is set up, that's the time. This is going to be 2.5. And this is in seconds. All the times are going to be in seconds. All the heights are going to be in feet. Okay, so basically on this little graph here, I'm just going to draw a little tiny dotted line. I know that this is 2.5 seconds that it's going to take me to get there. Okay, now the fireworks maximum height, like what would that be? All you're going to do is, this is just the y coordinate of the vertex, which in this case represents the height. So all you have to do is plug in what we got for the x coordinate of the point. So our height, we're just going to do negative 16. And again, this is where you might want to grab your calculator just to make it go a little bit faster. Everywhere I see a time though, now I know the time is 2.5 seconds for it to reach this maximum height. So we just have to plug in 2.5 to figure out where we would be at. So grabbing this, negative 16, please don't forget this. 2.5, you got to square that. I feel like people will kind of like type these in right and they'll forget to square that first piece for some reason. And then you plug that in. And I just simplified that, add 3 on the end. Maximum height here is 103 feet. So then, I know my graph is probably not drawn to scale. So up here, this would be 103 feet. So that point would be 2.5, 103 on the graph. Question. So, okay, see if this makes sense. Okay, so we said it would happen after 2.5 seconds. Remember, when we calculated this, this was after 1 second. So I'm just kind of, I don't know, whatever, maybe right in there. I'm just kind of eyeballing it. So like on the way up, I probably didn't estimate this very well, but it's going to hit the 67 after 1 second. So it'll hit the 67 on the way up, but it's going to keep going up before that force of gravity kicks in. So then it'll hit 67 actually over here somewhere on the way down too. But we're going to hit it on the way up, but it's going to go higher based on that little formula there. So you would hit it on the way up, but it's going to go a little higher than that. That's a really good question. Okay, now all we have to do to convert this to vertex form, super easy. We know the vertex, right? The vertex is that 2.5, 103. Now, vertex form here, I'm just going to use H and T instead of X and Y because we're talking about height and time. But normally we would see, right, the Y would be on that side. Your A value is the same in both forms. So if it's -16 up here, it's -16 in front of a set of parentheses. And I'm using T because X represents time here. It's just minus the X coordinate of the vertex. So it'd be minus the 2.5, that's squared. And then whatever the Y coordinate of the vertex is, you just copy that on the outside of the parentheses. So this would be plus 103. So just using that vertex, if you found the maximum height and the time it takes to get there, you got the vertex and you got the A value from the original problem. So you don't have to figure that out from your graph or anything like that. You have that. It's just going to be that gravity. Does anybody have a question? Yeah.
A little bit confusing.
Okay. This is your Y equals A times X minus H squared plus K. And I'm really not trying to confuse you because I know there's that general form has an H in it, but it doesn't actually represent height. They just usually use H and K to represent the vertex. That's the format I'm putting it in. It's the A value, same in both forms. So the -16 goes out in front of the parentheses. Now, probably if we had seen it in vertex form a couple days ago, if we hadn't talked about height and time, that would, where I have the T would have been an X. And then where I have the H would have been a Y. But the vertex is just what's being plugged in for your H and K there. That's what's going on. I should have written that formula so you guys could see it. Okay. Anybody else have a question? All right, let's scooch this up. Okay, we're just going to try this one more time just to practice. Okay, so it says the football is punted into the air with an initial upward velocity. So here's our speed. That's going to go in for V. And I'll give you guys that formula like within the question if we have it on a test or quiz. Initial height of 2.5 feet. So they're going to kick the ball like 2.5 feet off the ground, right? Write the quadratic function. So I'm just going to use that up there. So the height of the football, -16 T squared. The -16 is your force of gravity. I know this is super weird, but we're going to write 86.4 as our velocity. That's going to go in front of the T. So sometimes these have some weird coefficients. And then the initial height is 2.5. So plus 2.5. All right. In how many seconds will the ball reach a maximum height? And what is the maximum height? If it is asking you for a maximum or a minimum, either one. If it's asking you for a maximum or minimum, it is asking you find the vertex. In this case, since I got the -16, I know the parabola goes upside down because of the -16. So that has to mean that my vertex is a maximum, which is why they're asking us for a maximum. So all this is asking you for both of these questions are asking you for the vertex of that parabola. The first part of the question is asking you for the X coordinate. The second part of the problem is asking you for the Y coordinate. So all you have to do, this one, you're going to do -b over 2a, and then you're going to plug in -b over 2a for the second part. Those are the two things you're going to do. So it's just from standard form, because that's what we have. How do I find the vertex? I can't see it in standard form. I have to use that little tiny fraction to help me solve it. So with the new setup here, because this has different numbers, my B value is that 86.4. So opposite of B would be -86.4 divided by 2 times my A value, which is -16. You can just use your calculator if you want to, but it's really important. Either put parentheses around the bottom of that or figure out what that is. These problems, if they're all with the force of gravity as the negative 16, that number on the bottom of that will always be negative 32 because it's going to be 2 times negative 16. Or if you want to put parentheses, you can do that too. Now, I'm going to guess this is not a super number. So I'm going to say negative 86.4 divided by 32. Okay, this is not horrible. I got negative 2 point, or no, fail. Sorry, positive 2.7. Those negatives should cancel out. So that's 2.7. So that's the time. This would be in seconds. All the points are in the format time and height. So if I'm finding the x coordinate of the vertex here, I'm finding the time. When I find the y coordinate of the vertex, we're finding the height. All you got to do to find the height, we're going to plug it in like a Glade air freshener. So I'm going to do negative 16. I know this happens at 2.7 seconds. So everywhere I see the t, we're going to replace it with that 2.7 seconds. And I'm just following that formula that we wrote in part A, just replacing the t with 2.7. And again, this is where you're probably going to want a calculator because this has got some icky decimals going on. Don't forget to square that first piece, that first term, because that ends up being where we get the quadratic from. And then I'm going to do plus 86.4 times 2.7. I'm just going to double check I'm not putting this in wrong. And then you should just be able to simplify it. This is going to be 119.14 feet in the air. That's how high the football would go.
So all of this we can just plug into our calculator.
Yes, you can just plug it in. The only thing is you got to set up the little equation to find, like on that one, I have to set that up to find the negative 2.7. That negative b over 2a is really important. You guys will see that in our next unit as well. When we solve quadratic equations, you'll see that again. That comes up again. So that little bitty fraction is good to know.
So is that like a formula?
Yes. That's that. When we did 3-4, we did standard form, and it was like the vertex is negative b over 2a, comma, plug in negative b over 2a. That's really what I'm doing here. That's all I'm doing here. Okay. Now this one I'm going to try with you guys is a little bit weird here. So this one does not have an initial, it's not going to say like we're hitting the golf ball off like a table or something like that. So it's, let me just read it to you. Okay, so it literally just says Bree hits a golf ball from the ground. Initial velocity of the golf ball is 80 feet per second. So you don't have to write this, but let me write that general formula because I don't have it on this side. So it's negative 16 t squared plus the velocity multiplied by the time plus the initial height. That's that general, I'm off the screen a little bit. That's the general formula. So it just says she hits the golf ball from the ground. What's my initial height if I hit the golf ball from the ground?
0.
0. All right, so in this case, if you're hitting something from the ground, that just means the C value is 0. Okay, so let's go ahead and write a little formula for this. So this would be negative 16 t squared. Velocity is the 80 feet per second. I don't think I continued to read that. I apologize. Initial velocity of the golf ball, 80 feet per second. So that's how fast she's hitting it. So that second term would be plus 80t. And then if the C value is 0, we just don't have any more to the equation. Like if you wanted to, like I could put plus 0 here or whatever, but you probably would not see that on an actual equation. They would just stop writing it after the 80t. Okay, how long will it take to reach the maximum height? Let me just sketch a little tiny picture. So the main difference between this and the one we sketched before, she's going to hit the golf ball from the ground. So I'm just going to start at the origin. No height, no time has passed. So she's going to hit this golf ball up, and then eventually gravity is going to drag it back down to the ground. Difference here between this and the first question we did is the first question started at 3 feet. This starts at the ground. That's the main difference. So how long will it take to reach the maximum height? This is just the x coordinate of the vertex. So all you gotta do for that is your negative b over 2a. For this lovely question, your b value is 80. So this would be negative 80 over 2 times negative 16 again. So this would be negative 80 over negative 32. And why do I feel like I already did that today? I think we did this in one of the other problems, actually. This is 2.5. So that's going to be in seconds. So it takes 2.5 seconds to get this golf ball to the top of that lovely parabola. What is the actual height? We're just going to plug this in. So we're going to plug in negative b over 2a. So for this guy, the height, we're going to do negative 16 times 2.5 squared plus 80 times 2.5. And then we just don't have a plus anything else because we didn't have an initial height. So we're going to find this height. All right, so let me do negative 16, 2.5. Don't forget to square it. And then plus 80 times 2.5. And I'm just using the parentheses. If you guys are using scientific or if you're using graphing, you should be able to just use those parenthesis keys. You don't have to put like a multiplication symbol in between or anything like that. And my lovely height here, this is always in feet. If you're working with this formula, the time is in seconds, the height is in feet. So that's 100 feet. So if I want to come to the graph, actually, we can draw on this a little bit. I'm going to just try my best to go right in the middle because this should be the vertex. I did not do a good job drawing that. All right, so this would be 2.5 seconds. And then up here, this would be 100 feet. So I'm going over 2.5, up 100. That would be the vertex of the parabola. Okay, now these last two questions, I'm going to have you look at the picture and see if you can figure this out. That very first problem we did, you could not have done this because you're wrong. The very first problem we did, couldn't have done this because it started at 3 feet, did not start at the ground. If it starts at the ground, though, you can answer this question. So it says, what's a reasonable, we're not talking about full-on parabola, right? We would not go below the x-axis here because that would be underneath the ground. So just this first quadrant would be the map of this lovely golf ball. So reasonable domain, we're not going to do negative infinity to infinity because that doesn't make sense for the situation. That's why it says reasonable. So can anybody tell me, right, this is 2.5 right in the middle. This is a vertex. What would the x coordinate of that point be?
5.
Yes. How do you know?
Because the middle's 2.5, so the other half has to be 5.
Exactly. So if this is 2.5, this just like think of that where I drew that little line as axis of symmetry. If this is 2.5, this has to also be 2.5. So that would give me 5 as where I've come back. Basically what that means, the ball would come back down to the ground after 5 seconds. Okay, so reasonable domain. Okay, domain goes left to right. Reasonable domain. We're going to hit the golf ball. So no time has passed. So I'm not having negative time. And the golf ball is going to be back down to the ground after 5 seconds. So reasonable domain here would be from 0 to 5. And I'm going to use brackets for both of those because we're starting at time 0 and I'm ending at time 5 seconds when it comes back down to the ground. Can anybody tell me what a reasonable, so this is representing the time for this golf ball. The range for this situation would represent all the possible heights for the golf ball. What would you tell me for a reasonable range? What are all the heights that this, between what numbers do the heights of this golf ball go?
0 to 100.
Exactly. All right, you start on the ground, right? 0, you come up here to 100 and then you're going to come back down, but it's taken 5 seconds, but I never go above 100. So 0 to 100 would be our lovely range. Okay, and then we'll skip example 4. Let's just finish up with this question, but I do want to ask you this last problem. Okay, what's the height of the golf ball after 1 second? If they give you a specific time, you're just going to plug it in. So after 1 second, everywhere I see a time, or sorry, 1.5 seconds, we're just going to replace it with 1.5. So this will tell me the height after 1.5 seconds. So we're just going to plug that in. So let's see what it is. We got negative 16, 1.5. We're going to square it plus 80 times 1.5. Whoops. Should be 84 feet there. So this last question is really tricky. Okay, I'm just gonna kind of eyeball, maybe like right in here. So this is maybe about 1.5 seconds. And then here I'd be at, I did not do a good job drawing that, pretend that's better. Then I'd be at 84 feet. Okay, the second part of that question says, will the ball reach this height at another time?
Yes.
Okay, yes. How do you know?
Because it bisects, so that means the other half's the same.
Yeah, exactly. So you're going to hit 84 on the way up to that vertex, but then gravity's going to pull it back down. So you're going to hit, right? Let me draw a little line here.
At
Somewhere
3 seconds.
over here at what time?
3 seconds.
Is that 3 seconds?
Plus the 1.5, so 3 seconds.
What's the distance between 1.5 and 2.5?
1.
So where would it hit on the other side? Not 3.
3.5.
3.5, because you're just doubling it. Okay, so it's the distance. I didn't do a good job drawing that, but between here and here, the vertex is at the 2.5, right? So 1.5 to 2.5, that little distance right there would be 1. So mirror image on the other side, this little distance would also be 1. So this would be 3.5 here. It's the same on either side of the vertex. So this would be 1, this would be 1 between that point and the vertex. So I'd say yes. The other time is at 3.5 seconds. That vertex and that middle part of that axis, that is your axis of symmetry. So it's a mirror image. So you're going to hit 84 on the way up. You're going to hit 84 on the way back down. And those distances should be exactly the same between that and the x coordinate of the vertex. All right. Is anybody having a question? Okay. I'm just going to stop